Hello, Math 140 students. We will pick up on page 4, section 5.1. So here it's all about the exponents and scientific notation. So here we have a couple of rules. So we can see that we have an exponent. What we can do is we can distribute inside the parentheses. And if I have a negative exponent, this negative exponent isn't in simplified terms. So instead, to make it positive, we actually move direction. So if it's in the numerator, now it's going to go down in the denominator to make that exponent positive. So likewise, if the exponent's on the bottom and it's negative, then we can move it up to the numerator to make it positive. So it's all about making that exponent positive. And we know that anything to the 0 power will always equal to 1. And also you can think of it as if you have everything to the negative exponent, then what you can do is you can switch or flip that fraction. So let's put some of these rules into play. So here what you would do is you take this 3 and you distribute. So if I have 4 to the 5th, and then that exponent of 3 gets distributed. So I have a 3 and a 3. So now I have a 4 to the 3rd power, which is 64, and a 5 to the 3rd power, which is 125. So I have 64 over 125. And we know that anything to the 0 power or 0 exponent will always equal to 1. Now here, remember, we have to be careful whenever we have a negative exponent. So whenever I have a negative exponent, it's telling me to change it. So right now this is over 1. Well, to make it positive, I'm going to have a negative 5 to a positive 3 exponent. Okay? So now I have negative 5 to the 3rd power, which is a negative 125. So remember, you only make the exponent positive, okay? So the inside, that negative 5 still remains negative 5. So it's negative 5 times negative 5 times negative 5. Because negative 5 to the 3rd power is negative 5 being multiplied 3 times. So that's how we end up with that negative 125. For number 4, what we see is that negative exponent is only attached to the 2. So you think of it as 2 times a to the negative 6. So now I say, okay, it's 2 times, and now to make that 6 positive, it's going to go in my denominator. So by default, I'm going to have a 1 up on top. So really, this is going to be 2 times 1 over a to the 6th power. And for number 5, I have that negative exponent, so I'm going to move it up to the top. So it would be 3 to the 4th power, and 3 to the 4th power, well, that's 3 being multiplied 4 different times, which is going to give me an 81. And now for the next one, I have a negative 3. So what I can do is I can say I'm going to flip it. So it's going to be 4 over 3 to the positive 3rd power. So now I have 4 to the 3rd and 3 to the 3rd. So 4 to the 3rd power is 64. And 3 to the 3rd power is 27. So now I have my answer as a 64 over 27 for my final answer. Now let's talk a little bit about the scientific notation. A number expressed in the form a times 10 to the n, where a is a decimal, where the absolute value of a is between 1 and 10, and n is an integer. The scientific notation is a compact way of writing very large and very small numbers. So if I have a positive exponent, you would say a times 10 to the n, and so you move the decimal to the right, the number of places indicated by the exponent. When n is negative, then we're going to change move the decimal point to the left the number of places indicated by the exponent. So for example, we want to write this in standard form. So right now I have 7.305. Notice how that 6 is positive. So since that exponent is positive, I'm going to move it to the right. And I'm going to move it 6 spaces. So 1, 2, 3, 4, 5, 6. So notice how I have empty spaces. So I'm going to go ahead and put zeros in those empty spaces. So really my answer is going to be 7305000. So that ends up becoming my final answer. For number 2, our second one, I have a negative exponent on the scientific notation. So that means I'm going to move it to the left. So even though you don't see it, you can think of this as a 7.0, okay? If I had 4, it's the same as 4.0. If I had 8, that's the same as an 8.0, right? You can always make any number a decimal by saying it's decimal 0. So 7 is really 7.0. So that means I'm going to move this over to the left 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my decimal. So here I have 1, 2, 3, 4, 5, 6, 7, 8 zeros. So this is 0.1234567 8 zeros, and that's 7 there. Okay. Now we want to go backwards. Now we want to write these numbers in scientific notation. So here, remember your decimal, the way that we write scientific notation is we want this number to be greater than or equal to 1, but less than or equal to a 10. So here, of all of these, let's say if I put the 0 here, well, that's smaller than 1. So that doesn't work. So the first non-zero number is here, behind the 6. So this would be 6.08 times 10. And now you're going to count how many spaces you went. You went over 1, 2, 3, 4, 5 spaces. So that exponent is going to be a 5. And notice how that number is less than 1. So you have to make sure that you write it as a negative 5. And so that will be my final answer. Now let's look at problem number B. Here is a very big number. It's bigger than 1. So we want to make sure that we place the decimal very strategically. So we want to put the decimal so that it's less than 10. So if it's less than 10, well, 53 is too big. So instead, we're going to be thinking about that 5.3. So now I'm going to have 5.3 times 10. And all of those extra zeros, you don't really need to count them since it's going to be accounted for in that scientific notation. So let's say we put the decimal here. Let's see how many spaces you would have to move it. Let's count. 1, 2, 3, 4, 5, 6. So that exponent is going to be 6. So now I have 5.3 times 10 to the 6th power. All right. If you guys have any questions, please feel free to email me, your instructor, or the Math Success Center. Thank you.